Hey everyone, welcome into Unit 4, Day 11 notes. Today we are going to be talking about graphing linear inequalities and identifying solutions with two variables. We have two objectives today. The first one, number one, students will be able to solve for slope-intercept form, graph linear inequalities, and properly identify what type of line and shading is needed with 80% accuracy. And then we are also looking to make sure that students will also be able to determine if a coordinate is a solution to a given inequality with 80% accuracy. Okay, so let's go ahead and do a quick review for graphing linear inequalities. So if we are graphing linear inequalities and we see a less than or greater than symbol, we are going to be using a dotted line. If we see a less than or equal to or greater than or equal to, we're going to be using a solid line. If we are shading above, we are going to see greater than or equal to. And if we're going to shade below the line, less than or less than or equal to. Okay, so let's take a look at our first piece of information here. We're going to talk about solutions, okay, and what will make a coordinate a solution to a specific inequality. So the shading and line will help us determine what coordinates are solutions. Something that satisfies the equation. That's true when we plug it into the equation. When graphing less than or greater than, a solution will be in the shaded area, but not on the line. The reason being because less than or greater than symbols, it's not less than or equal to, right? The equal to will be if we are allowing the data to be considered a solution. If it's on the line, that would be considered equal to, but we're talking about not equal to, just less than or greater than. So let's take a look at some examples. So circle the solutions. We're going to plot the points and circle them if they end up being a solution. So we have 8, 6. So we go over to the right 8, and we go up 6. And that coordinate is in the shaded region. So we're going to circle it. It is a solution. -4, 0. We go left 4, up 0. It is not in the shaded region, so it's not a solution. 0, 0. Same deal. It is not in the shaded region, so it's not a solution. Over 0, up 7. This is definitely in the shaded region, so it's a solution. We have 5, -2. To the right 5, down 2. This one is on the line, and coordinates on a dotted line are not solutions. And then we have 10, 10. So over to the right 10 and up 10. That is definitely in the shaded region. Okay. So now let's take a look at the other situation, which is when we are graphing less than or equal to or greater than or equal to, a solution will be in the shaded region, or it can be on the line. So, or equal to means that it can be on the line and considered a solution. There are no gaps in the line, so there are no gaps in the answer there. Circle the solution. So to the right 4 and down 9. Well, that is pretty far from our shaded region or line. So that is not a solution. -4, 0. To the left 4, up 0. Well, that's in the shaded region. To the right 4 and up 7. To the right 4 and up to 7. That is on the line. So that is a solution because it's equal to the line. -10, -6. To the left 10. And then down 6. that is in our shaded region, so that is a solution. Over to the right 0, up 2. That is not quite on the line. And then 8, 10, to the right 8 and up 10. If we kept going a little bit higher, it might have ended up eventually being on the line or in the shaded region, but this one does not quite make it there. So that is not a solution. Okay, let's move on. So graphs only show us a small portion of the solution. Therefore, we can use the inequality itself to help us determine if a coordinate is a solution or not. We are going to substitute the coordinate values into the inequality to determine if it makes it true or false. If it's true, it's a solution. If it's false, it's not a solution. So we're going to try these here. So if you can tell, actually, I'm going to go scroll back up here. If we can see some of these coordinates might be tough to tell. Hey, is it on the line? Is it close to the line? Is it above or below the line? Depending on how well we graphed, because there is some human error when we are graphing lines on a coordinate grid. So that's when the solution is easiest to go through and see and check that process if we plug it into the inequality. If we plug it into the inequality, it will never fail us, right? Also, you can tell there are many coordinates that we would not be able to see if they were solutions, right? For example, if I plotted -6 and -15, well, that would be up here somewhere. Even though it's off the graph and we can assume the shaded area would still be up there, it doesn't quite tell us exactly. So that's where the inequality itself is foolproof here. So we can go ahead and we're going to try a couple examples. We have our coordinate x and y value. So we're going to plug in. We have our y value is 12. Our x value is 10. And now we just go ahead and do the math. So 12 is greater than 3 times 10 is 30. We're going to subtract 5. And we get 25. So is this true? Is 12 greater than 25? This is not true. This is false. So it is not a solution. All right, number 2, x, y. We're going to plug everything in. We have 18 for our y value. And then we have negative x. Now, when we plug in this information, make sure you plug it in using parentheses because it is very common for students to miss. This is a -1 times whatever we plug in for x. And then we have plus 3. So -1 times -15 is a positive 15. We get 18 is less than or equal to 18. It's not less than, but it is equal to. So this is true. So it is a solution. Okay, let's try this last one. We have x and y. We plug in 9 for y, 1/2 times 12 plus 8. Yep. So 9 less than 12 times 1/2 is 6 plus 8. In this case, 9 is less than 14. So this is true. Therefore, it is a solution. Okay, let's go ahead on to the next section on the back page. So, when graphing linear inequalities, make sure it is in slope intercept form. right? And again, slope-intercept form is y equals mx plus b, something we've been doing for a good portion of this unit. And then just a quick reminder from last unit, it says right here, reminder, flip the sign when multiplying or dividing by a negative. So that's something we have to get back into the habit of doing. We've been dealing with equal signs for this entire unit, or for a good portion of it. So now we just need to get back into that habit of when we're dealing with inequalities and we're multiplying or dividing by a negative, we need to flip the sign. So let's give these two a go here. Number one, we have 2y is greater than x plus 8. We have to get y isolated. So we want to divide by 2. And we divide everything by 2. So we're left with y is greater than, there's an imaginary 1 here, so it becomes 1/2 x plus 4. Okay, and then just like we also discussed in this unit, let's take a look at our important information. So this is our slope. We have 1/2. Remember, we can also graph that as -1 over -2 when we're counting out our slope on our graph. We have our b value for our y-intercept. Remember, we are writing this as a coordinate pair, and 0 is always, or our x value is always 0 for our y-intercept. It is a greater than symbol, so it is dotted, and greater than again means above. So let's go ahead. Just like this entire unit, make sure you have your student IDs ready to roll or a straight edge of some sort. And let's go ahead and graph. So we always start with our y-intercept over 0, up 4. And now our slope, up 1 to the right 2, or down 1 to the left 2. We're going to go ahead and draw in our dotted line. Awesome. And now we need to shade. I like to use a highlighter. Again, it's above the line. So anything in that shaded region will be considered a solution, which we're going to talk about that. So we're going to circle the solutions. -8, 0. We go to the left 8 and up 0. That one looks like it's right on the line, and therefore it's going to not be a solution because it's just greater than. It's not greater than or equal to. So that one is not going to be a solution. -4, -9. So to the left 4, down 9. It's not even close to our shaded region or the line, so it's definitely not a solution. 0, 5 over 0, up 5. That one is definitely in our shaded region, so it is a solution. To the right, 8, up 0. Doesn't quite make it. -2, left 2, and then up 6. That's well in our shaded region, so it's our solution, or it's a solution. Then over 10, up 10. That one as well is in our shaded region or above the line, so it's a solution. All right, let's try one more together. Number 2, we want to get y isolated, so we have to get rid of this 3x. We are left with -y is less than or equal to. Remember that term, that x term, needs to go first, and then we go ahead and write out our -6. Divide everything by -1. Remember, when we divide by a negative, we flip the sign. And now we have 3x plus 6. So our important information, we have our slope is 3. Our y-intercept is 0, 6. It is greater than or equal to, so solid. And then it's above again because it's greater than. We first start with our y-intercept over 0, up 6. Our slope, +3, so we go up 1, 2, 3, and to the right 1. And then we can do down 1, 2, 3 to the left 1. This time it's a solid line using our straight edge. Now let's go ahead and check our solutions. Oops, sorry, I need to shade first. Then we'll check our solutions. Above the line, right here, anything in this area. So -6, 4. Left 6, up 4. That is definitely in our shaded region, so it's a solution. 0, -6, over 0, down 6. That is not a solution. To the right, 8, down 1. Again, not even close to our shaded region. 0, 6, over 0, up 6. That is actually our y-intercept, so we know for sure that's on the line. So that's good. Then we have left 2, up 0. That is going to be our x-intercept solution. And then -1 and up 2. This is where we talked about it gets tricky, is if we're graphing pretty accurately, it'll be easy to tell. But if some of us are struggling with drawing our straight lines or not using our straight edges, then it's going to be tough to tell if that's a solution or not. Okay, go ahead, try 3 and 4. Come back and see how you did. See you in a few. All right, welcome back. Let's go ahead and check out the answers to 3 and 4. So in problem number 3, we go ahead and we solve, and there is no sign flip when we divide, so it stays greater than or equal to. We get a slope of -3/4. Our y-intercept is 0, 2. It's a solid line, and we're shading above. If we take a look, here's our solutions: 6, 0, 8, 0, 0, 7, and 0, 2. So 0, 2 is our y-intercept. As you can tell, right, it looks like it's a little bit off the line, but it should be right on the line because that is our y-intercept. So this just goes and shows the possible errors that you can see when graphing by hand, which is why we like to use the inequality itself to plug in coordinates if something is super close or we think it might be on the line. Okay, and we take a look at the next one. We get a sign flip in this one because we divide by a -2, so greater than becomes less than. Our slope is 3, and our y-intercept is 0, -2 this time. No equal to, so it's dotted, and it's less than, so it's below the line. So, excuse me, I did not shade. So here's below the line here. So we have 3 points that I've circled: 0, -2, 1, 1, and 2, 4. Those are all on the dotted line, and therefore they are not solutions because it's not or equal to in our inequality. Okay, so good job today. Thank you all for stopping by. I hope you have a great rest of your day. Peace out.